Section 10.2 Test for Independence. In a typical test of independence, sample subjects are randomly selected from one population and values of two different variables are observed. Two variable relative frequency are compared to one another within one population. So test for independence, we only have a one sample, but we'll be working on two categorical variables. So for the example, collect a large sample of people and record their marital status and income. So marital status and income, we do have two variables, but we only have a one sample here. And we want to test if these two variables are independent of each other. Contingency table, or you could call this as the two-way frequency table, consisting of frequency counts of categorical data corresponding to two different variables. So you can see we do have two variables. One variable is talking about the smoking habit, and one variable talking about the gender. So first, I want you guys find out the total. How many total males are there? How many total females are here? And how many of them are smoker? How many of them are non-smoker? So I'm gonna add it up here. We do have 31 male, 30 female. And we have 25 smoker and 36 non-smoker. So you could double check your work, added up these two guys, you should get 61. That will be equal to add up these two guys as well. And this is the contingency table, or you could call this as a two-way frequency table. One variable is smoking and another variable is gender. Highlight this one. This is the grand total. Okay, grand total. In a test of independence, we test the null hypothesis that in a contingency table, the row and column variables are independent. Okay, so we want to see if these two variables are independent. So look at the notation. Similar to the goodness of fit test, we do have an O, observed frequency. Okay, so from this contingency table, we perform the survey and then we write down the number here. So this is gonna be your observed frequency. And then we do have the expected frequency. I will teach you guys how to calculate the expected frequency in the contingency table. And then the R represent the number of the rows. Be careful when you count how many rows are there, do not including the labels and the total. So in our example, R equal to 2. And we do have the C represent the number of the columns. Again, when you count how many columns, do not including the labels and also the total. So the C is equal to 2 also. Okay, procedure for testing of independence will be used the chi-square distribution. First, verify the condition. Random sample. The sample data should be randomly selected from the population. Number 2, independent sample. So observation must be independent of each other. Similar to the goodness of fit test, right? Number 3, large sample. Expected count is at least 5 in each cell. So make sure you calculate the expected frequency and double check if they do have at least 5. Number 4, categorical data. Okay, the data should be in the form of counts of frequency for characters. Okay, find the expected frequency. This is gonna be your formula. Expected frequency equal to row total times column total divided by grand total. we use this example. Okay, first, let's say we want to find the expected frequency for male smoker. Okay, we're gonna call E11 this guy. Okay, E11. So the row total, which is gonna be 25 times the column total, which is gonna be 31. Okay, 25 times 31 divided by grand total, which is gonna be 61 here. So you're gonna get the expected frequency, that'll be 12.7. Now, I want to calculate the non-smoker. Okay, this guy, non-smoker male. So again, row total, 36 times column total, 31. And divided by grand total, 61 here. So you're gonna get 18.3. Okay, I want you guys try to find out the female smoker and then the female non-smoker. Find out the expected frequency. Okay, check your work. So E12, that will be 25 times 30 divided by 61. E22, last one, this guy, 36 times 30 divided by 61. Okay? And one more time, when you count how many rows and columns of your contingency table, make sure you don't count the labels and you don't count the total. So that will be 2 by 2. Okay, 2 by 2. So after you find the expected frequency, step 3. Identify the null and alternate hypothesis. Since we want to test the independence, we want to know if these two variables are independent, right? So the null hypothesis, row and columns variable are independent. And alternate hypothesis, they will be dependent. Test statistic, same formula, or you can use the calculator. P-value. So you need to calculate the degree of freedom. The degree of freedom, that will be R minus 1 times C minus 1. Okay, how many rows of your contingency table? How many columns for your contingency table? Okay, R minus 1 times C minus 1. And that will be always white tail. So find the p-value, chi-square CDF, test statistic, upper value, and then the degree of freedom. So same idea, when your p-value less than or equal to the significance level, we're going to reject. Greater than, fail to reject. Okay, last one, conclusion. When you guys draw the conclusion, make sure you guys gonna read the claim statement one more time and interpret in context of the scenario. Okay, for example, if you reject the null hypothesis, you reject it, you believe the alternate hypothesis is true. So you're gonna say there is sufficient evidence to conclude that the row and the column variable are dependent. Okay, you reject the null hypothesis, you believe alternate hypothesis true. If you fail to reject, then we do not have sufficient evidence to conclude the row and the column are dependent. This is the instruction how to use your TI-84 calculator to find out the test statistic and also the p-value. You also can use the calculator to find the expected frequency. But on the test, you guys need to show me your work so you could double check for it. Okay, let's do together. Example 1. The marketing consultant for a travel agency wants to determine whether travel concerns are related to travel purpose. The contingency table shows the result of random sample of 300 travelers classified by their primary travel concern and travel purpose. At alpha equal to 0.01, can the consultant conclude that the travel concern independent on the purpose of travel? So first, when you guys see the contingency table, fill up the total and then the grand total. Okay, check your word. And then verify the condition. So random sample, independent sample, and expected frequency at least 5, right? We do have n equal to 300, so should be okay. And then number 4, categorical data. Okay, find the expected frequency. I want you guys try fill up this information. So n, we do have a 300. How many rows do we have? We have only 1 and 2. Column, we have 1, 2, 3, 4. Okay. So I'm gonna calculate the degree of freedom here. You could calculate when you're working on the p-value. Now, I'm gonna find out the expected frequency one by one. First, that will be the hotel room in business. So that will be 180 times 74 divided by 300. Okay, row total times column total divided by grand total. Second one, the 1, 2 here, that will be 180 times 162 divided by 300. Okay, I want you guys find all of them. Okay, check your word. Okay, double check expected count is at least 5 in each cell here. Good. Now, we're gonna write down the null and alternate hypothesis. So these two variables, one is gonna be the travel concern, one is gonna be the travel purpose. Okay, so we want to know if they are independent. So for the null hypothesis, that would be the travel concern is independent on the purpose of travel. Alternate hypothesis, that would be dependent for these two variables. Okay, now let's use the calculator. Okay, so on your calculator, you're gonna click second matrix. Do you guys see the matrix here? And then use the arrow button, go to edit, enter. And then we need to input your matrix. So we do have a 2 row and 4 column. So 2, enter, 4, enter. And then you're gonna input like this table. So we have a 36, enter, 108, 14, and last one 22. Okay, and then the second row 38, 54, 14, and 14. Okay, right? 2 by 4 here. Okay, after that, we're gonna click on the stat. go to the test. Go up, you're gonna find chi-square test. Okay, section 10.1, that will be GOF. Section 10.2, that will be the chi-square test. Enter. So observed frequency, that will be on my A. Expected frequency, the calculator will be calculated by itself. So we could just go calculate. Enter. So that would be my test statistic. Okay, 8.158. You can write down the p-value to double check your work. Okay, and then you could go back here. Go to the second matrix. You're gonna see the B here, right? So go to edit, go to number 2 and enter. So this number you could check with your expected frequency. So here you could check with your expected frequency. Okay, 44.4, 97.2, 16.8. You could go down 21.6. Okay. Okay, now let's calculate the p-value. So p-value will be the chi-square CDF, lower value 8.158, upper value 1E99. And then the degree of freedom, which is gonna be R minus 1 times C minus 1. That will be equal to 3. Okay, so use your calculator again. Second bars, go to the chi-square CDF. So 8.158, 1E99, degree of freedom is 3, and then 0.0429. Okay? So compare with your significance level, that will be greater than. So we have a fail to reject the null hypothesis. So fail to reject means we do not have sufficient evidence to support the travel concern is dependent on the purpose of travel. Okay, last example. I want you guys try. Fill out the total, grand total, verify the condition first. Okay, check your work. Verify the condition. So simple random, independence, expected count is 5. So should be good, right? Because the grand total is 1,663. And then categorical data. Okay, now find the expected frequency. So we do have 2 by 2, right? R equal to 2, C equal to 2. So that will be degree of freedom, which is going to be equal to 1. And then 1 by 1, E11 here. So 892 times 447 divided by 1,663. Okay, check your work. Okay, now why don't know an alternate hypothesis? So we want to know if the gender of the tennis player is independent of whether a call is overturned. So alternate hypothesis is going to be dependent. Okay, test statistic. Use your calculator. You should get 0.221. Okay, right? That's a 2 by 2. And then p-value. So that will be lower value, upper value, degree of freedom equal to 1. You should get 0.6383. Compare with your significance level. That will be greater than, right? So fail to reject. Okay, conclusion. There is not sufficient evidence to conclude that the gender of the tennis player is dependent on whether a call is overturned. Okay, so test of independence. Talking about we only have a one sample with two variables and we want to know if they are independent of each other. Okay, that's it.